So here we've got some problems because it is not displaying the right type of data we want it to display. So what is the problem? Maybe the former used in the printf function is not the right one. I think it should be LF for double data types. Ah, yes, it is that. So it displayed 1, 2, 3, 4, 5, 6. And the reason why I called this field data, it is because this data field can store anything. It can be a student, it can be any other kind of data, data types, custom data types, but they are all these data items are stored inside this wrapper that allows us to navigate in the list. So now this is, we've been able to display it from the first item to the last item. So now what if we want to start from the last item to the first item? So we can, the last item here is the fifth one. We have the fifth one. And instead of using the next field, we're just going to use the previous field, the underscore prev field. And when you run this program, what you can see is 5, 5, 4, 3, 2, 1. So this is displaying this thing in the reverse order. So in this type of struct list, we have the head and we also have the tail. The first element being the head and the last element being the tail. Now we're going to create a function called append, and the append function will take the address for the first element, then append new element in it. So let's create append new. Then we pass in the first data wrapper, the address for the first data wrapper, then the data we want to append, the new data item we want to append. So I'm going to create a variable called a cursor. The cursor will allow us to move from one data item to another. So data wrapper type. So it will be equal to the first, and we say while the cursor underscore next is different than null, it means that this is not the last item in the list. So we're going to move the cursor to the last item. So cursor equal cursor underscore next. So the last item would have the next field set to null, then the loop will stop. Then after that, what's going to happen, since we have a new we are at the last item, we can now create a new item that will be a new last item. And then we can say cursor next. So the new next would have a preview set to cursor. There's multiple ways of doing the same thing, but basically it's like the old last, the next old last. I'm gonna rename the cursor to something like last, old last, just to make it more readable. Old last, and old last. Then here we're going to define something else called data wrapper type last. So for now, we don't have the last, but on this loop, we're looking for the old last, and then we create the last item or the new last. So create new item. The old last, we have the next item set to the last, and the last item will have a previous set to the old last, and still that works. Now inside our main function, we don't need these things because we have the append function and we can still append things up. Now let's delete these lines. I'm going to change that to something like first, and here we're gonna have something like underscore next. Also, we need to define the cursor variable. So we created the first item, and now what we can do is to append a new. We pass in the address for the first item, then the data we want to add will be, let's say, 2, 3, 4, 5, 6, and we have 1, 2, 3, 4, 5, 6, and still it works. One, 2, 3, 4, 5, 6. We can add as many items as we want. Now, the only difference with the previous example is that now we can loop in reverse. For example, let's create a function called print all. The print all function. Sorry, before we create this print all function, I want to make some changes. I want to say, okay, in order to have something at least like thing, we're going to set the first item to null first. Then we pass in the address of this variable to the append new. So at the beginning, the list is empty, and we can add up things one by one. So here we're going to add another start sign to say this is a pointer on the first item. And the last is set to null. So what we're going to say here is if the first item is equal to null, then the first item, we assign the new item to it. Else, we look for the last item and create the new item. So here I'm gonna say, instead of assigning the address for the first item to the old last variable, I'm gonna do the assignment from here. And format the code a bit. And still it is the same thing. The only things that change is how we link the new item to the previous item because we added the underscore prev field. So now we're ready to add the print all function. Void print all data wrapper type. We pass in the address for the first item. For the first item. And we can also add a function called print or reverse. It is still the same. You can say data wrapper type. You pass in the first item. But it will be convenient to have the last item else, because if we have the last item, we can directly start printing things out. But for now, we don't have this possibility. We may add that for future changes. So here, as usual, I'm gonna copy this thing, the cursor variable, print all, and the cursor variable is a data wrapper, pointer type. Okay, that's it. Now I'm going to copy the same code here and pass it inside the print all in reverse order. So instead of printing next, 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 we're gonna print using the pre field. But before, since we're at the first item, we're going to move the cursor back to the last item. So you're gonna say if the cursor is different than null, then we're gonna say while cursor next is different than null, then we're going to move the cursor to the last item. So here we move the cursor to the last item, then from the last item to the first item, we print things. So we have the both possibilities, printing in reverse order and printing in the normal order. So print all, we pass in the first item. Let's run this code and see what we get. Okay, compile the code. The output will be program. Oh, sorry. And to clear up the screen. Oh, yes. The append function should receive the address for the variable named first in order to be able to modify it. So I'm going to say append underscore like that. Here's the ampersand sign. And now we are ready to go. I'm going to compile this code. And we run the program. So we see display 2, 3, 4, 5, 6. And now we can display in reverse order by calling the function print all reverse. I'm gonna compile the code again. Now we see that 6, 5, 3, 2. So now we're able to move in the list in both ways. We have the next to move to the next item, the prev field to move to the prev item. Now let's make this thing a bit complicated. So as we said, this struct in the list or in the double linked list or linked single linked list, these acts like data wrappers. So they wrap around data, and we can move from one wrapper to another wrapper to look inside what is the data stored in there. The actual data can be of any type. So what if we define a new data type like our students, for example? So you can have this type def struct student, or let's say a person, and this will be a person type. The person has a name. I'm gonna say it has a name, an age, and a height. And then what we have here, we're gonna do some kind of magic. Uh, let's say this data field, we're gonna say now it is a pointer, a void type pointer, which means it can hold any reference or any kind of address. But this time, before we use the item or the data field, we first need to define what it contains. So I'm gonna say here, I'm gonna say char data type, for example. So we're going to agree, or let's say wrapper type, okay? So let's agree if the type is equal to something like the letter P, that means the data field is a person. But if it is, so P represent a person, and is represent is, let's say, maybe a fruit. Okay, we're going to define a fruit struct type. I want to show how flexible this thing can be. So let's have this thing called fruit, and int, this will be int. I want to say we have the fruit type. The fruit has a name and a color. So char name, we said the size will be 50, and we're going to say the color, it is a 40 length string, and let's add something like a weight. The weight will be an integer value. So what I'm going to do to organize this code a bit is to move, or is it better to have this thing in the same file for easy understanding, or maybe to create other files? You can let me know in the chat.
I think we should have them in other files.
In different files.
Yeah.
Okay. So let's move these things in different files. So this thing called the wrapper struct, I'm going to move, we're going to create a header file that can hold all these things. The main.h header file, if not defined, main header, we're gonna make it double inclusion protected. And let's move the structs and the function prototypes. So now we have this thing called a person. And we have this thing called data wrapper. So the exercise we're about to do is to say, we're going to create a list that can hold any type of data. So it can store a person, it can store a fruit, it can store whatever. This is not possible with arrays. Inside an arrays, you cannot store integers and double data types at the same time. But in list, with the new strategy I'm about to show here, we can understand how maybe Python list works, because Python list, you can store integers, you can store different data types. We can do the same things with lists, which we cannot do with arrays. Or it's complicated to do it with arrays, even if it's possible. So we have the person, the fruit data type, and I'm going to add a wrapper for each of these, a prototype for each of these functions. So we have create new, create new, create data. I'm going to call it data wrapper instead. So here we're going to call it create data wrapper. I'm going to move them in their own files. So data wrapper.c, and we're going to include the main header file, copy and paste the codes. Then we're going to include the standard lib libraries. And let's move back. The append new, the print all these things. I'm going to take the append new function and move it inside the data wrapper.c file. So anything related to the list will be inside this file. So append data, append new, append, let's say data, or append new. Okay, let's move back. So the print all, print, prev, all these are utility functions. So I'm going to create a file called utils. And inside this file, we include the header file. Then we include some of the things necessary for all these things, the stdio library, and maybe the std lib library. It's time to add the prototypes in the main header file. Okay, let's start with the data wrapper. We have create data wrapper, or I'm gonna say, yes, create data wrapper. Then append, the append function. I'm going to copy that. So we're going to have different appends. We're going to have append the person, append the student. We're going to have different functions for different data types, but for now we only have one single append function. So this is void, doesn't return any value. Okay. So I think, so we have the header file and we have the other things here. Okay. I'm going to delete the code inside the main file. Then we're going to create a file called students.c and another for persons.c. So these files will contain any function related to managing the student struct and the person struct. So the person struct will contain this field, include the main header file. Now we have the person struct here. So I'm going to do some simple changes to this data wrapper things. I'm gonna call it create wrapper. I think this is kind of better, create wrapper. So for this wrapper, we have the data field. We change the data field to void. So this is a void pointer type. It can be any type of pointer. So I'm gonna say, instead of passing a double for the data field, we're going to pass an address, but we don't know what data is stored in that specific address. Then we also have to pass in a type, and the type would be a character. So the type of the data wrapper. So what data it is storing. And I'm going to update the prototype from inside the create the main header file. So here we'd have the data that can be any pointer, but we also have to say what type of data it is. So the data wrapper hold the data and also an information about what is the type of data. Now, the next thing is to update the append function. So the append function, we're going to change it a bit. Instead of create new, we're going to have create wrapper. So we create a new data wrapper that we're going to add to the list. And the data it will receive, the field data is an address, so a null, a void pointer. And we also have to say what type of data it is. So that ways we know what type of data the wrapper is contained. Then I'm going to update the prototype from within the main header file. So in the main header file, we have void data and a char for the type of data we want to store. So we're ready to go. We're ready to go. Let's see for the students, how to create a new student and how to add a new student to the list. And then we're going to look at how to create a person and add a new person to the list. Then how to display this list. It's not student, actually, it is fruits. I want to say fruits. Okay, fruits. So fruits.c. And what is the other one? Persons. Okay. So we import it, and now we're going to create a new fruit type. So create fruit. And the fruit should receive the name, the color, and the weight. I'm going to include the standard lib libraries. So let's create a new fruit. So fruit type, we have a new fruit. We call the malloc function size of fruit type. Then it's time to set the field's values. So the new fruit weight is equal to the weight. And since the field name and the field color is not is a string, are strings, So we're going to copy the strings. So here I'm gonna say str copy. So new fruit name, we're going to copy the name into the name field of the fruit, and str copy new fruit color. We're going to copy the color to the color field.
Excuse me, Mohammed.
Yes.
Why do you have to copy the string values and you didn't do it for the integers?
Yes, here for the integers, these are primitive data types, but strings like the names field, these are arrays of characters. So if you do something like new fruit name equal name, so this is not copying the strings, it is copying the reference. For example, you might have two memory locations that hold two arrays stored in the memories, but each array has their own addresses. So if you do an assignment like that, you're copying the references, but we don't want to copy the references. What we want to do is to copy the content so that each would have two copies of the same character sequence. Maybe later someone might want to change the strings stored in the name variable somewhere in the program. And when it's changed, since the new fruit name is identical or hold the same reference, that might cause some issues. So we wanna separate copies. So the fruit has its own copy for the name, and the name variable also has its own copy, so they don't interfere. There is no interference when we're using them in different part of the program. That is one explanations, but there are other reasons. But for now, even if you do new fruit name equal name, it won't work because the compiler won't allow it. And so we can do a simple assignment here. And here we copy the content for the strings inside the string. So we copy the content of this array of character inside this array of character. The same thing goes for color. Now, what's the next thing? How to print a fruit. So we're going to add a function to print a fruit. Void print fruit. So we need to pass in a fruit type. So this print fruit function knows how to print a fruit. And let me include the S3IO library, S3IO library. And we have this thing, printf fruit. We print the name of the fruit, color. Let's say it will print fruit. Then it will print the line break. Then the next thing, it will print the name of the fruit. So that will be name I'm going to copy these lines, the colors and the weight. Color. And we have the weight. The next, we're going to print the fruit name. Here we're going to print the fruit color. And here we're going to print the fruit weight. Oh, this field is an integer data field. So I'm going to say %d. Now we have a function that knows how to print a fruit. So the next thing is to create a function that knows how to add a fruit to the data list, or to a list. For example, I'm going to say void append fruit, and we're going to pass in the list or the first data wrapper. So we're going to create a data wrapper that will hold a reference to the new fruit, then we add it to the others, to the list, for example. So I'm gonna say list, and then for the fruit, we need to pass in the name, the color, and let's say the weight. Oops, sorry. Okay. So what is going to happen here is something like that. We're gonna say call the append function. The append function will receive the data wrapper, the first one, and we're going to create a new fruit that will have the name, the color, and the weight. Something like that. Sorry, I'm going to create a new variable called new fruits, then call the function create fruits, passing the name, the color, and the weight. Then we call the append on the list. We pass in the new fruits, and the type will be an F. So now this will create a new data wrapper, wrap the reference for the fruit inside the data wrapper in the data field.